Good morning. Today's lesson is about dividing radicals. And when we divide radicals, we need to remember this equation. The nth root of a over b is equal to the nth root of a over the nth root of b. But b here cannot be equal to 0, or else this is going to be undefined. Also, the a over b cannot be negative, because if it's negative, we will have an imaginary number. So think about those two things. Okay, let me show you some examples. 1 over the square root of 3. The thing about dividing radicals is that we cannot have a radical in the denominator. So we need to remove that radical sign. And how are we going to do that mathematically? The process is what we call rationalization. So what we will do there is we'll multiply both the numerator and the denominator by the denominator itself. The denominator here is cube root or square root of 3. And by the way, if that you will do that if it's square root, because if it's cube root and fourth root, it's going to be different. But let's go to this example now. So what is 1 times the square root of 3? It is equal to the square root of 3. What is square root of 3 times 3? That is the square root of 9. 3 times 3 is equal to 9, and the square root of 9 is positive 3. So this is the answer for the first example. Let's go to the second one. We can express the square root of 1/2 as square root of 1 over square root of 2. Square root of 1 is equal to 1. And then just like what we did in the previous example, we will multiply both the numerator and the denominator by the square root of 2 because we want to rationalize this. And we do not want a radical in the denominator. The result is going to be square root of 2 over 2 times 2. That's 4. And the square root of 4 is positive 2. Right? Let's go to the next one. Now, if you remember the equation a while ago, that means we can express this as cube root of 20 over 4, which means that this is just equal to 5. Cube root of 5. All right. Now, with the 8 over 50, just like, what we did in the previous example, we can automatically simplify that, the 8 and the 50, right? Both of them are divisible by 2, so we can simplify that by writing square root of 4 over 3 times the square root of 25. Right? And the square root of 4 is positive 2. The square root of 25 is positive 5. And 3 times 5 is equal to 15. All right, let's go to the next one. Okay, 10 over 32, just like what we did in the past two examples, we can simplify this and we can express this as, we can divide it by 2, I think. So that's 5 over cube root of 16. Now let's rationalize this by multiplying both sides by not cube root of 16, but we will multiply that by cube root of 16 raised to 2. Now why is that? Because 16 raised to 2 times 16 is 16 raised to 3. We want the exponent to be equal to 3 so that we can simplify the entire 16. All right? Also, we will multiply the denominator by that. The result is cube root of 16 raised to 3. In the numerator, we have 5 times 16 times 16 square. Now, going back to the denominator, that's just equal to 16. In the numerator, we can simplify that 16 square. And by the way, in 16, there is a perfect cube factor, and that is what? That's 8. Cube root of 8 is positive 2. So meaning we can express the numerator as 5 times 8 times 8 because there are two 16s times 2 times 2. And what is the cube root of 8? It's positive 2. What is the cube root of another 8? That's positive 2. And then cube root of 5 times 2 times 2 is equal to 20 over 16. And of course, we can simplify that 2 times 2 is 4. And 4 over 16 is equal to 4. So the final answer is going to be cube root of 20 over 4. All right, let's go to the next example. All right, here again we have a fourth root of 3k raised to 3. We need to rationalize this by multiplying both the numerator and the denominator by, guess what? Fourth root of what? 3, not just 3. 3 raised to what? 3 raised to 3. Again, why is that? Because if we times 3 times 3 raised to 3, we want a 3 raised to 4 answer. And when it comes to the k, we will just multiply that by k because k times k raised to 3 is equal to k raised to 4. In the numerator, we'll also multiply that by 3 raised to 3 times k. All right. So the denominator is now fourth root of 3 raised to 4 and k raised to 4. This, multiply that to 6. That is 6 to the fourth root of 3. Okay, we can answer that or evaluate that 3 raised to 3. That's 27k minus, okay, multiply that this to fourth root of 5k k square and 27. Okay, that's 27 times 5. It's 135. So fourth root of 135 k raised to 3. So the final answer is going to be 6 4th root of 27k minus 4th root of 135k raised to 3 all over 3k. Right? Now we cannot simplify that 6 over 3 because we have 3 terms here. 2 terms on top, 1 term at the bottom. And there's no common factor of 3, 1. There's a 1 here on this side and 6 aside from 1. So that means this is our final answer. All right, let's go to the last example. And here we have a situation wherein we need to multiply the denominator by its complex conjugate. Before we do that, I can see that x squared is a perfect square number or a perfect square term. We can rewrite this as 2 over 3 minus x squared of 5. And I'm going to multiply that by the complex conjugate. Complex conjugate is just 3 plus x squared of 5. And then in the numerator, we have 3 plus x squared of 5. So you notice that the complex conjugate is just, we will just switch the sign of the second term, the one that has a radical. So from negative, now it's positive. The 3, the sign of the 3 doesn't change. It's still 3. In the denominator, you might be thinking, oh, I'm going to use the FOL method. No. You just need to multiply the first terms. That's 9. And the last terms. So minus x squared times square root of 5 times square root of 5 is equal to 5. Okay? In the numerator, distribute that. 2 times 3 is 6. 2 times that one is 2x squared of 5. So the final answer is going to be 6 plus 2x squared of 5 over 9 minus 5x squared. Can we simplify this any further? I think this is the final answer.